This video is designed to record some commentary about common student errors and common scoring decisions that were made for the 2015 AP Statistics exam. Problem number 6. I'm going to start with student F. And first of all, in part A, they said that no, method 2 would not be representing the population because it only represents either line A or line B, and that's exactly right. The answer had to contain the answer no, and then it had to somehow communicate that you're only representing one of the two populations, not all of them, and that's what they communicated. So they got an E for that part. In part B, the question was which of the two methods was likely used, and they said method 1, which is correct. The reasoning is because the mean of this sample is roughly around 6, which is the combined mean of both production lines, 5.9, 6.1, and that right there would have been enough, actually. So if they commented that the mean is 6, and that's what the mean of method 1 would produce, that would be sufficient. But they kept writing, which is always dangerous, but they said if method 2 had been used, then they would have had a mean closer to either 5.9 or 6.1, and that's not shown. So they really had another good argument. So they covered that very well, covered it twice actually, and so they were given, let me back up. The scoring for this, I should have mentioned, the first 3 parts actually go into making the first EP or I. So what I typically did when I was scoring is I just wrote checks down on my scoring sheet. So the first 2 parts are both correct so far, and if they get all 3 of the first parts finished correctly, then they get an E. So the third and final piece of section 1 is part C, and they said the question was which one would result in less variability. The right answer is method 2, and that's because it's just sampling from one of the production lines. And that would be sufficient. That's a good enough answer right there because it's only sampling from one of the production lines. But they go on to talk, and so they say which would have a smaller standard deviation than the combined standard deviations of the production lines. That's actually a secondary correct answer. So they've got 2 correct explanations. So they got all 3 parts correct, A, B, and C. Therefore, the first section of this problem is considered essentially correct. Part D was considered its own section because it's talking about describing the sampling distribution. The rubric writers decided this was a big enough component to stand alone and have its own section. So students, of course, describing a distribution, they need to talk about shape and center and spread. So you notice they talk about the mean is 6. That's the center part. They talk about the standard deviation being the population standard deviation divided by the square root of the sample size, and they get the correct answer. So that would be the spread. But notice they do not have shape. Nowhere in here is there a mention of normal model. This almost looks like an N here, but that's actually a mu sub x bar and a mu. So there is no normal. And so since they only got 2 out of the 3 descriptions, then they earned a partially correct on part D. Parts E and F were scored together, so each part is going to be half of another section. And so part E was the most missed part. Well, maybe not. Part D was missed a lot. Part E was also missed a lot equally. So students had a real hard time. What they were supposed to describe is a sampling distribution where you had a lot of sample means on one side and a lot of sample means on another side. And they did not too many students did that. They were supposed to basically depict a lot of sample means around 5.9 and a lot of sample means around 6.1. And not too many students were able to communicate that this is basically the sort of the shape and a sketch really of the distribution of the sample means would look something like this. It would be a bimodal distribution, and that's because it's the sampling distribution that they're describing. So this student said method 1 results in less variability in the distribution. That's true. They go on to talk about method 2 would have more variability because they would be sampling from both means, and yes, the sampling distribution would have more variability. But they never describe this sort of thing where there's a pile around 6.1 and a pile around 5.9. They never get around to describing that. And so because they never describe the shape and the distribution of method 2 sampling distribution, then this was not correct. So the most they can get out of this would be a P so far. In part F, it seems like it's asking the same thing, but really it's not. It's asking which one would have a sampling distribution where the sample mean is closer to 6 inches. And that's not exactly right. It's which one, if you sampled one just on one day, which method would be more likely to be close to 6 inches. So they answered that method 1 is more likely to produce a sample of 6 inches. And if you keep reading, it says production line A has a mean of 5.9, B has a mean of 6.1. Haven't really said anything new there. So the combined sample mean, now notice that's singular, so they are talking about a single mean on one day. So the combined sample mean from both lines should be close to 6. Close is a good descriptor, not exactly 6, but close to 6. Method 2, on the other hand, would have a smaller range, but its sample mean, and again that's singular, so they're talking about a single mean on one day on June 22nd, would likely be close to either 5.9 or, by parallelism, they're close to 6.1 inches. This is a correct answer. They are saying that it's going to be closer to 6 with method 1 because method 2, the mean is more likely to be either closer to 5.9 or 6.1. This was considered what rubric writers called the single day argument. They were arguing not from a sampling distribution, but from the point that if you picked a single day and you had one shot at this, the one mean that you get the one day is going to be more likely to be closer to 6 with method 1 than method 2. And so when you're talking about a single mean, we had to kind of think of this as a single day argument, and they had to say something similar to what the student actually did, and they did a fairly nice job. There are other arguments that students could have made, which were less likely and less prevalent on the test, and that was to argue from the sampling distribution that they had described in Part E. In fact, it says right here that based on your previous answers, it said that right there, not many students, I can't even think of any students that I remembered actually based their answer in F to what they said in E. Some of them, I guess they did, some of them did refer back, but some of them were referring back all the way to C, B, or A, which were not sampling distributions. They were distributions of samples, and so that would have been incorrect as well. And I think that's why they made this vague, because they wanted students to go back to the right previous answers, which would have been either from D or E. So overall, this student received an E for the first 3 parts, a P for Part D, and a P. EPP, and an EPP, according to the rubric, was a score of 2, which is developing. Sample I. In sample I, all 3 parts, A, B, and C, are good, and this was pretty typical. Lots and lots of students did A, B, and C correctly, and so they would have gotten an E for parts A, B, and C. Nicely done there. But unfortunately, this was also common. There was nothing for Part D at all, no shape center or spread, so that's an I. And then again, notice that in Part E, they said method 1, and they talk about some variability and something that might be true, but they never do describe that distribution where they would have sample means kind of around 6.1 and sample means around 5.9. They never get around to describing that method 2 would look like this, and that was what the rubric writers were wanting them to describe. So this part is not correct. And then Part F, they chose method 1 because it's more likely to produce a sample mean closer to 6. And here's their reasoning. This is where they start their reasoning, because if it factors both extremes, it will average out to be about 6. They're only talking about method 1. They don't talk about why method 2 would not be closer to 6. And so that's an incomplete answer. So that would be I for parts E and F. So the student got nothing for parts 2 and 3, but they got something for part 1. This was a score of 1, which was minimal. This was a very common score for part 6. And the last example I'd like to look at is J. Once again, the student answered A, B, and C correct. They did use a little different argument in part C. They said method 2, which is correct, would result in less variability because it's only from one production line. And again, if they'd have stopped there, they'd have been correct. They go on, though, to talk about the ranges. Now, had they just argued about the ranges, this would have been okay. Students could argue from either a shape standpoint. Let's see, am I saying that right? Which less variability? No, not the shape standpoint, but they could have argued from the range standpoint. And so if you combined the two production lines and sampled, your range would be a lot bigger than if you would just do it from one production line. So arguing from a standpoint of range would have been correct as well. But anyway, they got all 3 parts here correct. So section 1 was given and essentially correct. Lots of students somehow thought the sampling distribution would be bimodal. That is not true. They did get the mean, but there's no standard deviation given at all. So the second part is incorrect with only one of the 3 parts correct. And then we get to E and F. Part E, there are some true statements. If you read through this, they're saying some things that are true. But again, they never got around to describing a sampling distribution for method 2 that looks like this. So because they never did describe a sampling distribution of what method 2 would look like, they cannot get credit for this one. And then in part F, they say that method 1 is more likely. That's the right answer. Let's see if they explained it. More likely to produce a sample mean closest because it will consistently show a mean between both production lines and be close to 6. So far, so good. Now they just have to talk about method 2. They say method 2 is more likely to have a mean of either 5.9 or 6.1, depending on which line is chosen that day. Clearly, they're using the single day argument again. What dooms them, however, is they said close to 6 on the first method, but in the second method, they said it's more likely to have a mean of 5.9 or 6.1. They are stating, even though they may not mean it, they are stating that the mean will either be 5.9 or will be 6.1. The correct thing is they should have said close to 5.9 or 6.1, closer to 5.9 or 6.1. Or even the rubric said if they would have said less than 6 or greater than 6. They had to have that wiggle room in there, and they did not do that, so that's an I. So this student earned an EII as well, and EII is a 1, which is a minimal response.